Kristen Atchison, and we're going to continue our discussion of factorial designs. Today we're going to be discussing additional types of factorial designs and the applications that we can use, some of the applications that we can use for these. So an additional type is the higher order factorial designs. We've kind of talked about this a little, but not really overtly like this. So a higher order factorial design contains more than two independent variables. So any of those factorial designs that you see here, 2 by 3 by 4, that has at least 3 independent variables is a higher order design. There's no limit to the number of independent variables that you can have with a factorial design. You could have 6, you could have 20, you could have 428, but really the limit becomes about understandability. The more factors you have, the harder it is to understand what's really going on in your study. So an interaction with 4 variables can be very, very hard to explain. Even an interaction with 3 variables can be hard to explain. I mean, if you think about the complexity sometimes and the struggles that we have, that you as students have coming up with ways to describe the 2 factor interactions, you add a 3rd factor in there, and it becomes a lot more complicated. And then you add a 4th factor in there, and maybe the researcher can't even come up with a way to really discuss that, not to mention in a way that someone can understand it. So in concept, we have no limit to the number of factors we can have, but it really comes down to understandability. So it really depends on what those factors are and what you're really looking at. We can also use we can use factorial designs to expand or replicate a previous study. So one way, and we discussed this in class some, is instead of doing a whole nother study to replicate the previous findings, we can do the original study and add a second factor, which allows us both a replication. So factor 1 might be a replication, the independent variable for A might be a replication, and the new independent variable may be this extension of the previous study to find new findings, to kind of continue this discussion of the phenomenon. And we can also really use this nicely for validity and reliability, making sure that what we're finding is really true and making sure we're finding the same things over and over and over again. And again, this is giving us new information as well. That new independent variable is giving us new information that we didn't have previously. So here's an example from your text where they've expanded a previous study. What they did originally is they looked at college students and they took the delay period of certain amounts of time. We could either have no delay, pay them immediately, 50-month delay, 100-month delay, 150-month delay, all the way up to a 300-month delay. And this has to do with a future reward of money in 7 different delay periods. And they originally did this study with just college students to look, Green, Fry, and Meyerson did this with just college students to look at this phenomenon. Well, in the subsequent study, they were able to both replicate and extend. So the college student condition is a replication of the previous study. By adding 2 additional age groups, 6th grade students and older students, we've made this a new factor. And we can look at age now as a new factor. This participant age is our new factor. And the information that we're going to get about 6th graders and older adults, and the information that we're going to get across the different age ranges and any interaction that we might possibly have between age and delay period is all this new information that we're able to get. So we're still be able to look at this as a replication because we can look and see, did we find the same thing for the college students that we found the first time that they did the study? Whereas by adding the 6th graders and the older adults, we're also able to look at this new factor of participant age and how this affects this future reward. We can also use factorial designs to reduce the variance between subjects. So originally, a study may have looked at 2 large age groups that had a lot of variability, looking at people between 6 to 14 years old. Well, I mean, if you think about a 6-year-old and you think about a 14-year-old, that's a big difference, and everything in between. And so whatever their treatment is, any differences that they get, may really just be this between group variability. And we know know that that can be, a lot of that variability can be difficult statistically when we're analyzing our data. So another thing that they can do is to reduce this variance is to break up that age group of 6 to 14-year-olds into smaller age groups. The younger group maybe 6 to 8, the middle group 9 to 11, and the older group 12 to 18. By dividing them up into different groups and making this a factor now by looking at age as an independent variable, we can reduce the variability in each one of those groups and look and then at treatment. We can also use factorial designs to evaluate order effects. Remember, order effect is when we have one condition preceding another condition, possibly causing a problem, somehow changing how the participants are responding in some way. And so an original study may have just done the counterbalancing, where half the people got treatment 1 and followed by treatment 2, and the other half the people got treatment 2 followed by treatment 1. Well, if we look then at group 1 and group 2, depending on which order you have as a factor, we can see if there is in fact an order effect. If we have a main effective order, well, then we have an order effect. What we are hoping then to find in a factorial design like this is no main effective order. We would still want a main effective treatment, and we would also want no interaction between order and treatment. We would really just want a main effective treatment. But by looking at order as an independent variable, we're able to evaluate if there are order effects and if this could be impacting then the findings that we're getting for our differences between treatment 1 and treatment 2. So again, when you're evaluating these order effects, we're really just trying to see if there are any. Is our main purpose for using order effects, order as an independent variable, for using it as a factor to just kind of determine, do we have order effects? We have 3 possible outcomes for this. The first one is the one we really want, fingers crossed, no order effects. That's the one we're looking for. And again, you don't want an interaction there either. They're going to want a main effect of treatment in that previous example, but you wouldn't want a main effect of order, and you wouldn't want a interaction of order and treatment. You can also find symmetrical order effects where we just get better the next time we do it, and we get better equally the next time we do it. And you can also find non-symmetrical order effects where it's not as predictable of an order effect. Any of these 3 things are possible in this usage, this application of factorial designs. So here are some different ways that we can kind of evaluate them. Here we have, again, group 1, have half the participants get treatment 1, half the participants get treatment 2. Group 2, half the participants get treatment 2, followed by treatment 1. And again, what we're going to be looking for here is we want to see a main effect of treatment, but not a main effect of order. And this is what this example is showing us here. It's showing us no main effect of order. That's why if you look at that top part where they're adding 0, they're saying that they're adding no order effects. And so we look at treatment, 20 and 30, those marginal means are different. So we have evidence that there may be, in fact, a main effect of treatment. And then we look at the marginal means of order of treatments. We have 25 versus 25. That doesn't lead us to believe that there's any order effects, which is, again, what the researchers are going to be hoping for. And then you're going to want to look and see if there's an interaction. So we have a difference of 0 between order of treatments. We have a difference of 0 between treatment 2, group 1 versus group 2, and we have a difference of 0 between group 1 and group 2 on treatment 2 as well. We have a 10-point difference for treatment 1 versus 2 for the main effective treatment, and that 10-point difference holds up inside as well. So we do not have an interaction, and we do not have a main effect relating to order. All we have is that main effective treatment, which is what the researchers are looking for. But this way, they're able to make sure that order effects are not an issue. It's an additional control that they can put on the study to really look at and make sure order effects were not impacting the dependent variable at all. So in addition to just counterbalancing, using this factorial design allows the researcher to actually have more control than they would have had if this wasn't a factorial design. Here's another example. where we have this one has an order effect. If you look at treatment 1 versus treatment 2, we have a difference there. Good, we've got a treatment effect. That's what we're hoping for. This one does not have a main effective order, 27.5 versus 27.5. There's no difference here. If we look for an interaction, though, we have a difference of 0 for the marginal means of order effects. But if we compare group 1 and group 2 for treatment 2, we see that there's a difference of 5 there. So we do have an interaction. And again, you could look at the graph really easily and also see that interaction. So this would be a situation where we have an interaction. Something is going on with our order. We don't have a main effective order, but we're still having an interaction. So order is playing a role in our dependent variable. And so we're not able to say that all of our differences between treatment 1 and treatment 2 are due to the treatment. It may again have some implication of order. Remember, when you have an interaction, you lose some of that external validity for your main effects. And this would be the situation here. In this example here, we have the same kind of thing. In this situation, we actually have an order effect and an interaction of order. So this is what that would look like. And this is a symmetrical order effect where we have, again, a same number is added to both. And these are in your text as well, so if you care to spend some more time with them. But again, look over this and see that we both have a main effect here of treatment. We have a main effect of order, and we also have an interaction of order and treatment. In this situation, then whatever we find about this main effect of treatment doesn't necessarily have very much external validity. We aren't able to say that the difference is here due to our external validity because we have this situation of counterbalancing, that order is somehow playing a role. And so we're not able to then really look at that. And again, this is a within subjects design. This would be a situation where you're like, okay, well, order is playing a big role here. So it may be most important then to do this as a between subjects design, so that we can really not have to worry about order since it is playing such a big role. And again, Factorial designs allowed us to be able to find that out, allowed us to look at this and see that this was the issue. So that's going to wrap it up for us for Factorial designs. Your participation question for today is on Factorial designs. Please complete that for Wednesday, and we're going to move into 2-factor ANOVAs now.